Alright guys, welcome back again. Let's share the screen. And what we have now is, so we try to visualize things, right? We remember things we should have visualized most of the time. So let's say we have a given, so we given that trace of A transpose A is equal to 50. Alright, and rank is 2. Rank is equal to 2. And we have to prove that one of the lambda is one of the eigenvalue is in the range minus 5 to 5. This we have to prove. Right? So let's do. We have a, let's say A n cross n matrix. Then A transpose A is equal to trace. So trace is what? So for any matrix, trace is equal to sum of eigenvalues. Eigenvalues always, right? So sum of eigenvalues. Traces sum of eigenvalues, or we can is equal to sum of diagonal elements. Alright. So what is the trace of this matrix? Trace of this matrix will be sum of square of all elements. This is also right. So this is like this could be also like power 3. So our sum of square of all elements. Sum of diagonal elements. So what are the diagonal elements of A transpose A? What are the diagonal elements? This is the question. So diagonal elements are Column vector is sum of square of all elements. So that these are the a11 square plus a2 square plus like this. These are the diagonal elements of this. So these are the diagonal elements. So right. So what next? These are the diagonal elements. So what are the wait a minute. I should ask this question. Our friend, right? Our friend is this. Let's say we have given that trace of A transpose A of A is 50. A transpose A transpose A is 2. Then prove that is the space for this response. What did you say? Complex root solving equals simplex. This is true. Complex root solving equals simplex. Right? So guys, let's try to tackle this problem. Right? So we have a 10 cross 10 matrix A. We are given, and we are told that the trace of A cross A is 50. We are given the trace of A is 50, right? And the rank of A dash A is 2. We need to prove that one of its eigenvalues range by 5 to him. Let me recall some linear algebra concepts. Wait, A dot A dash A is a symmetric matrix because the transpose of a matrix multiplied by itself always symmetric. Alright. This is so symmetric matrices have real eigenvalues and they are diagonalizable. Also, so real symmetric matrices are always have real eigenvalues. So what is this? So that is symmetric matrix. So one more thing to remember in value. Any matrix, for example, any square matrix, transpose if we multiply the transpose of the matrix by itself, then this gives us already symmetric matrix. Okay? So symmetric matrix has real eigenvalues. So we already discussed that if it matrix is real, symmetric matrix always have real eigenvalues and they are diagonalizable. That's so one more thing. Symmetric matrix always have real eigenvalues and diagonalizable. Right? So symmetric matrices have real eigenvalues and they are diagonalizable. Also, since the rank of A dash A is 2, that means that so symmetric matrices have real eigenvalues and they are diagonalizable. Diagonalization means there is a proper traceable diagonal. Also, what that means that particular matrix is diagonalizable. What does that mean? What does a matrix be diagonal diagonalizable means? A matrix being diagonal means that it can be written in a diagonal form. Like the form usually suitable basic eigenvector. More important equation in diagonal if there exists a vertical matrix P. The diagonal matrix D such that P D P. Alright. All known matrices are elements of zero. P is a matrix whose columns are linearly independent vectors of A. Alright. Alright. So and H is a H equal to 3. Mm, then, yeah. So this is diagonal means. Also, since the rank of A dash A is 2, that means that out of 10 eigenvalues, only 2 are not 0, right? What? What? Also, since the rank of A dash A is 2, that means out of 10 eigenvalues, only 2 are non-zero, right? Because the rank is equal to the number of non-zero eigenvalues of for symmetric matrix. For any symmetric matrix, so rank is equal to 1 more thing. For symmetric matrix, rank is equal to number of non-zero eigenvalues. So rank of A dash A is 2. That means that out of 10 eigenvalues, only 2 are non-zero. Suppose the rank is equal to the number of non-zero eigenvalues for symmetric matrix. Trace of a matrix is a sum of its eigenvalues. So if the trace of a dash is 50, then there are two non-zero eigenvalues. Their sum is 50. Let me denote those two eigenvalues as lambda 1 and lambda 2 is equal to 50. But wait, Lorem says that one of eigenvalues is in minus 5. That would mean that either lambda 1 or lambda 2 is an interval. But if their sum is 50, how can one of them be minus 5? Because if they both are positive, then their sum is 50. So each would be positive, but maybe there is something I missing here. Wait, hold on. A dash A is a positive semi-definite matrix because for any vector ax, x dash a, ax square is A dash ax is ax square is greater than or equal to 0. So all eigenvalues of A dash A should be non-negative. That makes sense. Therefore, the eigenvalues lambda 1 and lambda 2 must be non-negative. So their sum is 50 and both are non-negative. Therefore, both eigenvalues must be positive. Both are non-negative. Sum is 50. Both are non-negative. Therefore, both eigenvalues must be positive. So how can we an eigenvalue be range manifold if they are all non-negative? Unless the problem is considering eigenvalues of A itself, not A dash A. Wait, no. The problem mentioned eigenvalues of A dash A. Wait. What? Mentions this. Does problem mentions this? Yeah, right. Excuse me. But it has a non-negative eigenvalues. So maybe interval 0.5, but the problem is in answer. That seems contradictory. Maybe there is a typo. Or perhaps I misinterpreted the problem. Wait, let me check the problem statement again. It says given a trace of A dash is 50, rank of A dash is 2, then prove one of its eigenvalue is dense. If it A is a triangle, wait, A is a triangle matrix, so A dash A also 10 cross 10. Rank is 2, and A dash A has a non-zero eigenvalues. Case is 50 so that two eigenvalues sum is 50, but since A dash A is positive semi-definite, those eigenvalues are non-negative, so both lambda 1 and lambda 2 is greater than or equal to 0, and lambda 1 plus lambda 2 is equal to 50. Therefore, each eigenvalue is between 0 and 50. But how does that lead to an eigenvalue that makes it because all eigenvalues are positive? Wait, maybe that is answer there. Is the problem asking about eigenvalues A? Or is the problem is still saying one of its eigenvalues where it's refers to A dash, but I can't have negative eigenvalues unless A is not a real matrix. But the directly specify weight A is a square matrix usually unless it finds otherwise B is its real. So it's 70 positive limits. So I will not know negative. Therefore, five values are 10, 0.5, not 550. So maybe the problem is T. What the other vehicle trace of erasure of eigenvalues. Rank of erase is 2. So 2 non-zero eigenvalues. Non-zero eigenvalues. Server music is 2 hours for the match live. So what is this question saying, guys? We have trace of A transpose A is equal to 50. Yes. Its symmetry matrix rank is 2. So rank is number of pivot elements. Number of pivot elements means the number of non-zero eigenvalues. Number of non-zero eigenvalues. So free variables is equal to 8. 8 linearly independent eigenvectors for lambda is equal to 0. This is true. 8 Get linearly independent eigenvectors for lambda equal to 0. This is true. This is true. While it is independent, all right. So is that we have at least lambda is equal to 0 power 8. Lambda is equal to 0 power 8 at least. Because why is that so? Chemistry. Why is that? Foundation. So let explanation let is to matrix number of which is equal to 2 to equals to and then values into 8 is to 8 also for k is equal to 0. For k is equal to 0, yes. K is one value. Into next k is equal to 0 or 8. Yeah. Yeah, please rank is still it is still $1 million. Less than a rank community. Right. We will have space solution which is very infinite vectors. Right. Since the attribute vectors lie in an analysis, they correspond to eigenvectors of A. Let the eigenvalue k equal to 0. This means A is actually 0 to value 8. So as algebraic multiplicative of three states can be accommodated. Alright. Next is complex. Next thing is complex roots always come in pairs. Yeah. Complex root always occurs in pairs. So complex roots we can say eigenvalues. Eigenvalues is the root of the equation now. So a plus ib comma a minus ib. We come into always in pairs. It will be always given to. And we have I square is equal to minus b. Remember this. Square to minus b. Any square diagonal lower or upper triangle that is given in all right. Alright. One more thing I use. One more thing. If A is real matrix for symmetric matrix, for any symmetric one more thing you need to remember. You need to remember. For any symmetric matrix, for any symmetric matrix, rank is number of non-zero eigenvalues. Right? If A is a real symmetric matrix, let's say A is a real symmetric matrix, then eigenvalues of A is if A is a real symmetric matrix, let's say, if n lambda 1 and lambda 2 are two different eigenvalues of A, then U and V are eigenvectors corresponding to lambda 1 and lambda 2. Then U and V are linearly independent and perpendicular, or we can say orthogonal to each other. This is if A is non-round symmetric matrix, eigenvectors are not necessarily orthogonal. But this is only true for symmetric matrix. Then it is also diagonalizable. This is true. I don't know. From previous doubt, in a matrix is given upper and lower rank matrix, then we can say that diagonal elements are given values. If we ask to find eigenvalues, then we have अगर हमको पूछा जाता है कि find eigenvalues है ना, then we have to do a minus lambda करना पड़ेगा, a minus lambda करना पड़ेगा क्योंकि When we transform a matrix in upper or lower triangular matrix, जब हम इसको ट्रांसफॉर्म करते हैं ना, the eigenvalues might change, but the product of eigenvalues in this case does not change. Right? If we were determinant, then change the matrix upper or lower level elements. If we want to find eigenvalues separately, then we have to do a minus lambda I equal to 0. But if given matrix is already upper or lower triangle, then consider are given values as it is. So one more thing, there is a given matrix. This is a diagonal, principal diagonal. So if we change this matrix in lower triangular matrix, right? Then product of this is determinant of matrix A, right? And this is also product of eigenvalues. But this is forgiven. But what we are saying, if we are already given this, then the as it is, a11 is lambda 1, a1 a22 is lambda 2, right? But if we have to change this in upper or lower triangular matrix, the product does not change, but particular eigenvalues may change. Right? This is very important. And T of n is equal to theta of n square. Let's say we have to do theta of n square. Then we give this like T of n is equal to C of n square. C theta, no? So theta which is C. Then we have 30 as 3000, let's say. The C of n square, n is 100, मान लो. So C is equal to 3000 upon 100, 10 to the power 4, 33.3 C is like this. Johnson counter is self-decoding circuit. Why is this so? Is helpful today. Why explain? Why Johnson counter self-decoding is also counter twisted ring counter is a type of separation counter when the output of the last flip-flop is inverted and fed back to the first flip-flop if the counter well, each state has a unique pattern with only one group of bits. Set of one is a predictable sequence. What? A Johnson counter is self-decoding counter because each state has a unique pattern. State has a unique pattern with only one group of bits set to one bits set to one in a predictable sequence. This means that each state can be directly recognized without requiring additional decoding logic like AND or OR. How does it work? Flow 0 0 0 1 1 1 1 1 1 1 1 1 0 Every state has a unique pattern with single continuous block of ones. This means each state can be identified directly by reading the output without extra decoding logic. State can be identified. No. Comparison with a binary counter. A regular binary counter uses an external decoder for to decode identify the state. Not a unique state pattern allows. Hmm. राइट सेल्फ रिकॉर्डिंग इस देखिए सेल्फ रिकॉर्डिंग का क्या मतलब है मतलब ये है कि हम उसकी स्टेट्स को आइडेंटिफाई कर सकते हैं ये मतलब है सेल्फ रिकॉर्डिंग है आइडेंटिफाई द स्टेट्स उस स्टेट को पता कर सकते हैं ये रूट कोज में सेल्फ रिकॉर्डिंग का ये मतलब है कि हम उसको सेल्फ रिकॉर्डिंग काउंटर का ये मतलब कि हम उसमें जाते हैं और उसकी स्टेट को पहचान सकते हैं। इन टनल मोड it encrypts payload and IP header. In tunnel mode, it encrypts payload and IP header. What does mean? What does that mean? In tunnel mode, it encrypts payload and IP header. Digital signature preserves data integrity. Explain. Explain this, guys. In tunnel mode, in IP encapsulation, encryption, integrity, protection. IPsec. Internet Protocol Security. Internet Protocol Security. Tunnel mode. Both the payload actual data and the IP header are encrypted. Payload IP header, all right. And encapsulated within an IP packet. This provides confidentiality, integrity, and authentication. इंटीग्रेशन तो हो जाएगी कि हाँ ठीक इंटीग्रिटी चाहिए कॉन्फिडेंशियलिटी मेकिंग इट सिक्योर फॉर VPNs and site to site communication. How tunnel mode works: encrypt of payload and IP header. The new IP header is added to potential. This makes it equal to trackers to recommend the original sender and receiver. Encapsulate process. Payload data original the IP header plus payload. Precision security. IP security uses authentication header AH or encapsulating security payload ESP to ensure integrity. ESP provides encryption and integrity by using an hashing algorithm like HMAC SHA-256, HMAC SHA-1. Digital signature और HMAC based integrity checks ensures that the तो जो ESP प्रोवाइड करती है इंक्रिप्शन और इंटीग्रिटी तो वो क्या यूज़ करती है, वो ऐसे में होती है, जो दो एलिमेंट होती है, एच मैक एंड एस एच 256। ठीक है, एच मैक और एस एच वन जो होती है, ये भी होती है। जो डिजिटल सिग्नेचर है ना, इंश्योर दैट कि encrypted data hasn't been altered during transmission. That the encrypted data hasn't been altered during transmission. तो ये क्या करती है, इंश्योर करती है। डिजिटल सिग्नेचर है, एच मैक बेस्ड इंटीग्रिटी होती है। ओरिजिनल डेटा encrypted data hasn't been altered during transmission. Even if the attacker intercept the packet, any modification will be detected. The packet will be discarded. Right. Total mode, storage security, IP address masking, integrated protocol common for VPNs. VPN के लिए टनल मोड यूज होता है, ये ध्यान रखिएगा। अच्छा स्माइली भी दे रहे हैं, स्माइली भी दे रहे हैं तो this recursion thing is very fascinating. User level thread can block the process for IO operation. बिल्कुल कर सकता है, क्योंकि उसको पता नहीं होता ना सीपीयू की एक प्रोसेस ब्लॉक कर रही है, या ब्लॉक प्रोसेस या फिर कोई थ्रेड कर रहा है यूजर लेवल। और क्या है इसमें, ईच ऑफ लाइट वेट प्रोसेस कैन बी मैप टू कर्नल थ्रेड। कोई भी लाइट वेट प्रोसेस हो एक कर्नल थ्रेड को तो वो आसान हो सकती है। ईच ऑफ लाइट प्रोसेस कैन बी मैप टू कर्नल और यूजर यूजर थ्रेड। थ्रेड वन, यूजर थ्रेड वन, लाइट वेट प्रोसेस कर्नल थ्रेड वन, वन वन। नॉन यूजर लेवल थ्रेड, lightweight process one, kernel thread one. Well, this is many to one. वन वन मैपिंग क्या है, एक जो यूजर लेवल थ्रेड है, एक जो यूजर लेवल थ्रेड है, so one user level thread, एक जो यूजर लेवल थ्रेड, एक यूजर लेवल एक ही कर्नल लेवल थ्रेड से मैप होगा, ये तो वन वन मैपिंग है। ठीक है, वन लाइट प्रोसेस के लिए। लेकिन एक लाइट प्रोसेस से मेनी यूजर लेवल थ्रेड होंगे, लेकिन वो मैनी जो यूजर लेवल थ्रेड होंगे वो एक कर्नल लेवल थ्रेड से जाके अटैच होंगे। ठीक है, ठीक है। ये तो वही बात जो डाइजेस्ट एल्गोरिथम ऑलवेज विजिट ईच नोड एट मोस्ट वंस। डाइजेस्ट एल्गोरिथम हर एक नोड को एट मोस्ट वन एक टाइम ही विजिट करती है। वाई इट प्रोड्यूस द इनकरेक्ट रिजल्ट इन द प्रेजेंस ऑफ नेगेटिव वेट एज। तो जो अगर नेगेटिव वेट एज है तो ये इनकरेक्ट रिजल्ट पैदा कर एक ही बार करके मतलब सही नहीं दे सकती। जो शॉर्ट हो सकता था और वो ज़्यादा शॉर्ट नहीं कर पाता उसको। ठीक है, तो इनकरेक्ट रिजल्ट नेगेटिव एज की उसमें ये देती है क्योंकि एक बार विजिट करके माइनस कर दिया, माइनस किया प्लस वो विजिट करती जा रहा हूँ तो वहाँ से वो नहीं कर पाती है। एग्जीक्यूशन टाइम फॉर सिंगल इंस्ट्रक्शन। अच्छा, अब देखो जैसे पाइपलाइन में चलेगी पाइपलाइन, तो सिंगल स्टेट जो सिंगल कोई भी इंस्ट्रक्शन है तो पाइपलाइन वाली ज़्यादा लेगी उससे, क्योंकि उसमें ओवरहेड्स होते हैं। ठीक है, सिंगल इंस्ट्रक्शन वैसे मल्टीपल हो तो उसमें कम नहीं होता है। कॉम्प्लीमेंट लैटिस इज प्रॉपर सबसेट ऑफ बाउंड्री लैटिस। कॉम्प्लीमेंट लैटिस क्या है? प्रॉपर सबसेट ऑफ बाउंड्री लैटिस, भाई इसको एक्सप्लेन करिए क्या है कॉम्प्लीमेंट लैटिस। कॉम्प्लीमेंट लैटिस इज proper subset of bounded lattice। तो कॉम्प्लीमेंट जो लैटिस होता है स्पेशल टाइप का लैटिस है, लैटिस। अच्छा, बाउंड्री लैटिस का टाइप है। मीनिंग एवरी कॉम्प्लीमेंट इज ए बाउंड्री लैटिस बट नॉट एवरी बाउंड्री लैटिस कॉम्प्लीमेंट मेक सेट ऑफ। ठीक है, बाउंड्री लैटिस इज कोई भी लैटिस बाउंडेड होगा, ए ग्रेटेस्ट एलिमेंट ऑन टॉप एंड लीस्ट एलिमेंट और एग्जांपल बाउंड्री लैटिस पावर सेट प्रीसेट यूनियन। राइट, ठीक है। कॉम्प्लीमेंट ए कॉम्प्लीमेंट इज बाउंड्री लैटिस वेयर ईच एलिमेंट ए हैज ए कॉम्प्लीमेंट बी सच दैट। अच्छा, तो देखो बाउंड्री से समझो कि मेरे टेस्ट की बाउंड्री है सब। बाउंड्री मतलब बाउंड्री है सबकी एक गेट है, ये फिर बाउंड्री है बाउंडेड है हर बार की उसमें सकते एक टॉप होता है एक बॉटम। तो जी, और जो कॉम्प्लीमेंट होता है हर एक का के पास एक मतलब हर एक एलिमेंट के पास तो कोई ना कोई कॉम्प्लीमेंट होता है। कॉम्प्लीमेंट तो लीस्ट ग्रेटेस्ट ये चीज़ ध्यान में रखनी है। फिर हमारे पास क्या है, फिर हमारे पास है कॉम्प्लीमेंट्री प्रॉपर सबसेट बताइए। प्रॉपर सबसेट क्यों है? क्योंकि ये बाउंड्री का ही पार्ट है। ठीक है, हाँ, तो यहाँ से ऐसे राउट पर जाएगी फिर इस पर जाएगी, तो इसका ट्रांसमिशन फिर प्रोपेगेशन, इसका ट्रांसमिशन बस ट्रांसमिशन क्यू डिले अलग है, ट्रांसमिशन प्रोपेगेशन क्यू डिले ट्रांसमिशन प्रोपेगेशन। ये तो बता रहा हूँ, तो बता रहा हूँ ये जनरली खत्म नहीं होती है। वायबल प्रोपेगेशन लेटेस्ट। Alright guys, thank you so much for watching. We will meet in the next video.